All right, our third video, excuse me, is going to be the characteristics of trig functions for our specifically sine and cosine curves. The first couple of slides here, first couple of parts of this, really there's not much for you to write. It's just more informational. We talked about this at the end of the last video, but it gives a nice little graphical representation here. Remember that the amplitude is going to be the distance from the midline, either up to the maximum or down to the minimum. So as you can see here, they've given you the amplitude is 1, and that's from the midline up to the max, or if you went from the midline down to the minimum, it's still a distance of 1. The midline is what cuts it in half. Basically, the easiest way to find the midline given a graph is to find the halfway point between the max and the min. So if the max is 1, the min is -1, the halfway point would be at 0, so it's the equation y equals 0. And then the period, remember, has to start at, well, it doesn't have to start at the y-axis. It's just the easiest place for us to start counting. You could technically start anywhere, but you have to go through the max, through the min, and then back to the original starting point. So once again, you can kind of see that if I use the highlighter, we started at 0, goes up, there's the max, keep going, keep going, keep going, there's the min, now get back to the starting point. That took it 2 pi to get there, and that is what this is telling us right down here, that the period was 2 pi. So for sine, remember that the graph starts and ends at the midline. For cosine, I'm not doing all the highlighting and stuff, it's exactly the same idea. This is going to start and end at the maximum. Well, since it starts at the maximum, obviously it has no choice but to go down to get to the minimum before it starts to come back up to the maximum. All the stuff there is pretty much the same idea. Sine and cosine are going to be the two primary graphs. Cosine can start at a different place other than its maximum once it gets shifted, and we will deal with that eventually. We're not getting to that quite yet, but sine will always start at its midline. All right, so let's go ahead and look at how these things are going to be transformed based upon the actual equation, because that's going to be the important part, is can we do this from an equation? Seeing it from a graph isn't going to be difficult, but seeing it from an equation, it might be a little bit more challenging. Well, if there's one thing you should recognize here, and this is stuff that we have been dealing with for the entire year, is that we've got some 3 very familiar letters up here. We've got A, H, and K in both equations. And you know what? They do exactly the same thing that they have done for every other equation that we have dealt with so far this year. Doesn't matter what kind it was, they all deal the same thing. So if you remember correctly, K is going to be your vertical shift. It's going to shift things up and down. H is going to be a horizontal shift, which is going to go left and right. And then A does a couple of things. A will actually stretch or shrink something vertically, and if A is negative, it will flip it. Typically, it reflects it over the x-axis. In this case, it's actually going to reflect it over the midline. So let's see how all that stuff plays into the amplitude, midline, reflection period, and this thing called phase shift, which we haven't seen before. It's a new vocabulary, but it really is the same as something else. So the amplitude, remember what I told you in the last video, the amplitude is always positive. The nice thing about amplitude is it is represented by our letter A. It's going to be the thing which is out in front of the sine or the cosine curve. It's the number out in front of that. So we're going to say that our amplitude is the absolute value of A. That's the 2 bars around the A. That's the absolute value. It just means that it has to be positive, always. And again, it is the distance from the midline to the max or the min. I'm not redefining it here. It is on the other pages. The midline is very, very easy to find from these equations because the midline is the K value. If you think about it, K shifts everything up and down. So the midline will go with it. The midline is simply y equals K. It makes it very, very simple to find. A reflection would be a negative A value. So if you have a negative A, that will be a reflection. And it will reflect over the midline. So it'll just flip everything over the midline. The period, the amount of space it takes to go through one full cycle. How did they define it? I'm going to just define it the same way they defined it in the previous page. The length of one cycle of the graph. So we'll say the same thing. It is the length of one cycle of the graph. And I'm going to add must go through the max and min before returning to the starting level. It's got to go through its max and min before returning to the starting level. And then the phase shift. Okay, that's one we haven't talked about yet. We haven't seen it yet. But the phase shift is the H value. It's a fancy way of saying your left and right shift. So the phase shift is left and right, and it is your H value. And remember that when you shift left and right, most people remember that whatever's in the parentheses is going to go in the opposite direction of the sign. So if it's a minus H, it'll go to the right. If it's a plus H, it'll go to the left. And it'll go to the right or left that many units. All right, so that takes care of the 5 things that we need to know. There's technically one other shift that we are not even going to deal with. And that's what's called a period shift. It's not something that we will deal with at all for this year. If you end up taking pre-calculus at some point in time, you will probably see that. All right. So by looking at either the graph or the equation, we should now be able to figure these things out. So let's look at the graph first. If you want to try these, I would strongly suggest going ahead and giving that a shot and pause it and then come back. I think you can probably figure most of these out pretty easily. If not, again, I'm going to walk you through it. So go ahead and pause it if you want to give them a shot yourself, and then come back and we'll talk about it. All right, so the amplitude on the graph. Again, the amplitude is the distance from the midline to either the top or the bottom, or the easiest way to figure it out is what is half of the distance from the top to the bottom. Well, let's see. The top is up here at 4. Oops, come on, draw. There we go. Top is up here at 4. The bottom is down here at -2. Well, that covers a total of 1, 2, 3, 4, 5, 6 spaces. Well, what's half of 6? Well, that's 3. That's your amplitude. And it also makes it easy to find the midline if I do the counting that way, because again, it covered 6 spaces. So 3 spaces from the top or 3 spaces from the bottom is going to put us at our midline. So if I simply count up 3 or down 3 from either the top or the bottom, we're going to get to y equals 1 right here in the middle. And remember, the midline is an equation, so it is y equals 1. So that's how you would do it graphically, by looking at the graph. If you do this from the equation, it's actually probably even easier. The amplitude is the number out in front of the cosine or the sine function. Well, here's the number out in front, that -2. But remember, amplitude is always positive. So even though it says -2, the amplitude is just 2. And the midline comes from the k value. Well, the k value is out here. So my midline, again, remember, it is the equation of a line, is y equals 3. Okay, and it's really that simple looking at the equation. So we'll go down to the next one. The amplitude, it's the number out in the front. That's 1/3. And the midline comes from this piece over here. That's -4. So it is y equals -4. And that's how you find amplitude and midline from the equation. All right, one more slide to go. And this one is just asking us to determine the period. So again, the period has to start and end at the same level, but it has to pass through both the max and the min before we can stop it. So again, I could start and stop this anywhere. I could pick right here to start it and figure out where I would have to stop it. That's not a very convenient place to start it from because just figuring out the distance between that and wherever I'm going to go is not going to be easy. So the best thing to do, again, if possible, is to start it at the y-axis. Well, that's right there. Now I'm going to trace the graph. And I'm going to go back to the highlighter to do this. If I trace the graph, remember I have to go through the max and the min, doesn't have to be in that order, before I get back to the starting level. Well, my starting level is 2. So I'm going to start here. I'm going to go through the min first. Okay, we're good there. Got to go up here. Can't stop at 2 yet because I haven't touched the max. Now I've touched the max. So I'm going to come back down and I'm going to stop at 2. So right here is my stopping point. So I went from here to here. Oops, I covered it up. From here to here. Well, that covered a distance of pi. So my period in that case is pi. And then it would keep repeating that over and over again. Okay, one more. This one, we are going to start right down here on the y-axis. Okay, that's already at our min, so we're good getting through the min. We have to go through the max before I can return to that starting level. So we start here, go up through here, we're at the max. Now I got to get back down to the starting level, which is right there. So that's where it stops. What's the distance that I covered to go from here to here? That is 4 units. Notice that it does not have to have a pi in it because this one just went 4 units. But that's how you determine the period graphically. All right, I think that is good enough for this last video. You should have everything that you need to for this lesson.